All right, folks, it's Bass Action, back in action here. In this video, we are going to talk about proportional area and proportional volume. If you have your foldable, you should be on the inside on the bottom right, where you'll find these two examples for proportional area and proportional volume. Now, back in chapter 7, all right, back in our chapter 7, in our similarity chapter, we talked about the fact that the scale factor for two similar objects could be found by comparing any two corresponding parts. So if the figures were similar, then any two corresponding parts would give you the scale factor, or vice versa. So if you had the scale factor, then you would know that the corresponding parts would be in that same ratio. Now, when we're talking about proportional area and proportional volume, we're going to use that same idea related to the scale factor, but our formula is actually going to be a little different. Essentially, what we need to make sure at all times is that our units match, okay? So we always want to make sure that the units match. Scale factor was measured in just units, but of course area is going to be units squared and volume is going to be units cubed. So proportional areas, if you want to compare areas of two figures, we would need to know the scale factor squared because area is squared. And proportional volume, we would need to know the scale factor cubed because volume is cubed. So let's take a look at an example here. We're given that the scale factor of two similar solids now is going to be 3:2. So we always want to find what we're given. So we've got our scale factor here, and we've got our is going to be 3:2. So we can go ahead and we can write that down. Scale factor is 3:2. Now it's written in that colon format, but you can write it as a fraction as well. We're also told that the area of the larger prism is going to be this 216. Now, if we want to go set up a proportion, a nice fraction equals fraction, involving our area, we are going to need to work with a scale factor squared. When we square a fraction, we need to remember to square the numerator and the denominator. So our ratio of our areas is not going to be 3:2, it's going to be 9:4. That is the ratio that we're going to need for our proportion. So the ratio of the areas will be 9:4, and now we can take the area that we're given for the larger and put it into our proportion. Since this is to represent the larger, we find where's the larger value here, and we're going to make it match up. So we'll put our 216 there. Then, of course, we want to find the area of the smaller, and we'll just cross multiply. So we'll have our nice 9x. We'll probably bust out a calculator and get a nice 864. So the area of the smaller figure will then be 96 feet squared. We can take a look at another example here related to proportional volume. On this problem, I started you off with the ratio of the volumes. So back here, I started you with scale factor. Here, I'm going to start you with the ratio of the volumes. So if we start with the ratio of the volumes of 64:27, that means I've started you with the scale factor cubed of 64:27. Now, I'm going to typically set these up so that the numbers that you're given here will be perfect cubes. If they are not perfect cubes, then what you will need to do is reduce your fraction first. Once you reduce it, you'll find that I am going to set them up as perfect cubes so that you don't have to do anything special in your calculator. So what I know here is that if our scale factor cubed is 64:27, I need to go backwards, and before I can consider anything else that the problem is asking, I need to figure out what was the original scale factor. In other words, what number did I multiply by itself 3 times to get 64, and that would be 4. What number did I multiply by itself 3 times to get 27? That would be 3. So my scale factor is 4:3. Now, if this problem asked me to work with area, I would take my scale factor and I would again find the scale factor squared, just like we did here. However, let's keep reading, and what we'll find is that this problem says that a side, remember the sides will be measured in units, is going to be 60 feet, and we want to find a corresponding side. So we can just work with our scale factor. So I'm going to use my 4/3. Again, I'm told that the larger figure is the 60, so the 60 will match up with the 4. I'll put an x in the denominator here, and I'm going to cross multiply. So 4x equals 180. So the length of my corresponding side in the smaller figure will be 45 feet. So it's very important to always set up in your proportion. If you're working with volume, then this should be the scale factor cubed, area, scale factor squared, or just measures of segments in it, then you can do scale factor. And also always pay attention to what you started with. So what were you given and where do you want to go? You must always ask before you start any problem.